the paper has to be framed in a general attempt to related to the studies we are carrying out. Actually, it's a contribution to the future internet, and the problem is that the future internet is becoming very complex, more complex than the current networks. And we need to understand as operator what is the role, what is the contribution that the operator can give to this new environment, to this new ecosystem. So, essentially, distributed or centralized decision logic could mean, should we pursue the current models, control models that we are proposing, for instance, in IMS, or should we move to something else? Quality of service is incidental in this way, is an example how to implement things using centralized or distributed decision logic. This is the outline of the presentation, so we will start from talking a little bit about the quality of experience, then we will talk about a new architecture, and then use cases and some suggestions or conclusions. The quality of experience. I'm not an expert in quality of experience, but I was trying to access the Wi-Fi network here in this room, and I had some problems. And I don't know exactly if it's my fault, because I don't know how to access to that. I don't know if it's my new PC. We just changed the PC and probably it's not properly configured, or it's the provider of the service. So now let's imagine that all of us are connected to this Wi-Fi area network here, and we start to do heavy download of the files. For sure we will experience a bad quality. Who is the fault? Service Italia, the provider of Wi-Fi, the telecom operator that is not Telecom Italia for sure, or it's our fault. So the quality of experience that the user are going to experience depends on many factors. What is happening on the terminal, what is happening in one or more networks, and what is happening at the edges, at the other edge. What happens if Google is not providing a responsive answer to the queries of the users? Actually, the big data centers are an important point for providing the quality of experience. So altogether, these environments will be part of this quality of experience. If they do not talk each other, if they do not coordinate each other, if they do not share something, even if we are providing the best network with the best available quality of service, probably not in all the cases we are going to support the expected quality of experience of the user. So it's a deperimeterization program, the quality of experience. What are the current paradigms for providing services and quality of service? On one side, on the upper layer, is the traditional way operators are providing quality of service. A lot of physical resources and a few control layers resources. The resources on the upper layers are directly controlling, and say to the physical resources what to do. On the other side, the client-server model totally disregards the network. It's a pipe, it's a socket. I just open, send the data, receive the data. Probably the two are not adequate to what is going on currently. Actually, what is happening is the system, the communication environment is becoming more and more complex. Think to the smartphones compared to the telephone set that you had at home or at your grandmother's home. Very simple, very controllable by the network. And so there was a very strong coupling about the quality of the device with the quality of the network. But now it's not anymore. If you take an iPhone, there is a lot of processing, a lot of configuration inside that phone, and a lot of capabilities. So terminals will be resources of the network, of this communication environment, and they have to share their goals. Another point is that the new communication environment will change. It's not anymore just about connectivity. It's about processing, it's about communication and storage. Roberto before was talking about the importance of storage. And there is even more things, objects, smart objects. They will be part of this communication environment, and they will create a lot of complexity, especially at the edges of the network. And probably the local aggregation of these objects will create problems if too many objects are located in a small location. They will demand a lot of connectivity. And these objects are mobile. They are pervasive and they are mobile. So they can move. Think to people protesting against the Italian government. That's quite usual in Italy. So if they move along the streets of Rome, probably they congest a different part of the network. And that is, in a way, unpredictable. So the quality of experience will depend on the dynamic aggregation of many resources. It will depend on the power of the terminals. It will depend on the capabilities of the network. It's a very complex way of dealing with the quality of experience. So more complexity of the entire communication ecosystems. And the point is that this complexity will aggregate at the edges. If you talk to any operator, they have the goal to flattening and to make their network simpler, introducing optical, fiber, reducing the number of nodes. So our network is going to be simpler, or we hope it will be simpler. But what is more complex now is at the edge. On one side, we have plenty of terminals. On the other side, we have huge distributed systems like cloud, grid computing, and we are in the middle. By the way, the client server is not exactly a distributed paradigm. It's peer-to-peer is distributed. Client server is not. What is Apple doing, what is Google doing, is recreating a sort of big mainframe into the network. They are creating a virtual, unique world. If you make a research on Google, they will tell you just what is inside Google. What is external to Google, they will not tell you. They will not know. So they are creating a sort of mainframe. So this is the complexity that is going to be in the communication environment. So we were saying it's not only communication, it's storaging, processing, sensing, and actuation. And we have to move from a cooperation in order to find a viable path, the best effort approach of the current internet, to something that has to be a kind of cooperation in order to find a viable virtual environment to execute services and to exert communication. So it's even more complex. You see, the different colors are sensor, communication resources, storage resources, and processing. So this is something that we are not ready now to see. But it's the real problem. Communication will a mix of storage, processing, and sensing. So what we are trying to do is to come out with some principles for a new network operating system. You know, the history of programmable network, if you want, is an up and down. In a certain ages, for instance, at the end of the 90s, a lot of people were talking about programmable network. Then nobody. Now it's with the future internet, a lot of people are talking again on the needs to have a network operating system, programmable network and things. What are the problems? There is a big problem related to that is called ossification of the internet. The internet has many problems. Security, for instance. Another big problem is mobility. Internet didn't come with mobility integrated. So we have to support new mechanisms for mobility. Another point that is an advantage and a disadvantage of the internet is that there is a clear cut between the service layer, the application layer, and the physical network. In peer-to-peer network, for instance, there is no awareness of the physical resources. So if you want to download a file, and the file is, I'm in Palermo and I want to download a specific file, and that file is in Rome and in Australia, the network doesn't make any judgment. And there is the possibility that that file is downloaded from Australia, consuming a lot of resources from many different providers. So we need also to provide a view on the infrastructure to the application in order to allow them to provide a better usage of resources and to be aware of what they are consuming. Consider also, we made a study in Turin, and Turin is a city of almost 1 million of inhabitants. We were able to figure out that less than 10 people in Turin are doing more than 20% of the traffic. So what about the other 1 million of people? We have to provide to them fair service. So we need also to come with solutions that guarantee a fair use of the available resources, according to the contracts and the agreement we have with all the customers. Another point, the end-to-end principle. The network has to be as much as simple as possible with intelligence at the edges. I think it's a good principle, even for an operator, so we have to stick with it. And then we need to introduce in the future internet the capabilities of distribution. Once again, peer-to-peer is used in a bad way in certain cases, but it's very clever. It's a very nice paradigm. Think to BitTorrent. BitTorrent is providing to you the capability of downloading very large files, cutting them in pieces, and that is due essentially because our network now, our broadband network, is asymmetric. We can download more than we can upload. So they divide in pieces and they upload small pieces, they put together and they send it to you. So distribution of functionalities is very important because it allows you to create a number of services exploiting the capabilities of millions of terminals. Think to what is going to happen with the smartphones. They will be providing processing and storage capabilities that are currently in my PC. They are now dual core, they have a lot of memory or storage, and they will be part of this processing. Okay, so we are envisioning a sort of network on networks. That means there will be resources that are networked, provided by a company. They will be connected to public networks, maybe from different operators, and they will be connected to clouds of processing and storage environment. What we have to do is to try to decouple the physical nodes, the physical infrastructure, from a virtual view. But there has to be a link. So we need to virtualize the nodes, but to keep a relationship between the virtualized node and the physical resource that is supported. And on top of this, we need to create applications that will exploit the capability. Virtualization is very important because it's a good way for providing a closed environment in the secure sense, and it's also a way for saying to the user, this is what you can consume. This is the virtual resource that you can consume. What are the technologies that we are looking at with special interest? Well, first of all, peer-to-peer overlay networking. The other point is we need to provide a sort of, again, quality of service, and what we are aiming at is to make the nodes intelligent in such a way that they can diagnose it. They can say, my behavior is changing, I'm malfunctioning, and I need to shut down, but while shutting down, I will ask to another node, another autonomic node, to replace my functions. And so we need to create a sort of self-organization within the communication network. So one resource can hand over in an intelligent way the functions and the mechanism to another one in order to guarantee that the service is going on. Again, Google, what is doing for any single query that the user is sending to them, they are replicating the query 3 times. It's statistical. And they triplicate the data set for answering to these 3 queries. And so they distribute the query in 3 different places. So if something happens in one place, the other 2 will continue processing. So it's a simple way of providing a sort of autonomic capabilities. And that is something we have to exploit also in the network. The other point is resource virtualization. So we need to abstract the resources in order to allow the people and the designer of services to think in terms of how much resources they are, how many resources they are consuming. And then other things. So we came out with a blueprint of our architecture. On the lower level, we have physical resources that should provide open interfaces in order to be programmable. Then we want to organize this network operating system as an overlay of virtualized resources. And we will do a lot of layering and abstraction. Another point that we came out along our experience is that we need to have a programmable abstraction. There are certain services and certain programmers that need to work at the lowest level possible of the operating system, because otherwise the service is not implemented. For other services, programmers can work at a very high level. For instance, connect A to B, and A is a number of a person and B is the name of the person. Other needs to say, connect this node with this other node, guarantee that the jitter in this connection is of this type, and this kind of things. On top of this, we need to provide, again, open interfaces, because probably the role of the operators will be in this platform and not in the services. We have tried to provide services, but the number of programmers that is outside that could use this net is much more than the programmers that we have in any and in combined telecommunications. So we started the zero-touch management is the idea that networks will be so complex that they need to self-configure. That is part of autonomic computing. I think that more than 60% of the problems in the networks are due to bad configuring of resources. So if we come out with something that will automatically fix this problem, it's much better for the operator and also for the other providers. So we make an abstraction and a separation between communication network control and communication resources and other resources like storage and processing. It's a little bit like here in Palermo, in which you see you have buildings built on top of Roman ruins, on top of those Arabic, and then on top of those Normans. Network control plane will perform connection management. It will try to guarantee that the objective of that communication will be achieved. The resource control plane will perform the allocation of IT-related resources and will guarantee that they are working properly according to the contract. The knowledge plane is in charge of providing an abstract view, a virtualized view of what is going on in this heterogeneous environment. We will see that this architecture could be centralized or distributed according to the needs of the application, but according also to the willingness to distribute the function from network operators or providers. So this is what we would like to do, is to virtualize and to support the slices. The slices are particular views of the specific resource, and to develop an application environment on top of which application can be run as an overlay. Some use case. The first one is flexible routing path allocation. We took a lot of inspiration from OpenFlow, that is an initiative from Stanford University, I think also Berkeley, and another American university. So the idea is that in order to put in place a communication environment, several domains should be involved. This domain could be the user domain, it could be a company domain. In this case, you see, domain 3, that by chance is ruled by an operator, will take a leading role. That means that we'll coordinate the allocation of resources for the entire inter-domain system. And we'll provide an abstract view of those resources to applications that could interact with this logical view of the system in order to create, to modify the entire system. The other view is that each domain will provide a logical view of their resources. And it will be the distributed network control plane that will put together all the virtual resources, and they will provide different logical view of the system to different applications. Also, the application could be more or distributed. So there is a main difference here. Here the systems are just cooperating. Each one is maintaining control on their resources, on their allocation. It's a matter internal to domain 1 to make available the virtual resources. It's a matter of domain 3 to make available public network resources, and so on. The aggregation will allow the development of application. Well, complexity here is a little bit more detailed than in the previous case. Another point is, the other use case is related to storage. We were triggered by the fact that in peer-to-peer networks, even if users are turning on, running the PC with the information you are willing to achieve, and then they shut down the PC, well, they do that in 1 hour, and a half of hour time. You still have the availability of that information 24 hours per day. So the problem is that the advantage is that there are plenty of systems that dynamically offer that information. Well, you can virtualize this stuff using the mechanism that we have seen before, and so you can say there will be available to you stable storage capabilities that are based on highly dynamic clusters of dynamic resources that are turning on, stay online for a while, and then turning off. The problem is that we need plenty of those and rapid mechanisms to exchange the information inside the cluster. So that is another example. At this level, we are able to support the autonomicity. That means that information is stable, is always available. So, coming back to the centralized versus the distributed, my personal view, but is debatable and is debated inside the company, I prefer a distributed view. Because what we need to do with the future internet is not allow that there will be lords of the internet, big companies that do rule the internet. When you want to contact me, you go through LinkedIn, you go to Google. and my identity, my information, my data actually pertain to them, it would be much more in the distributed fashion to say I make a query to a sort of DNS and I get the information about Roberto Minerva, or where Roberto Minerva is storing the information about him that you can access. It's a totally different model, more distributed instead than the centralized one or the client server. So, but in any case, there could be certain situations, for instance, when some companies do not want to deal with the intricacies related to how to virtualize the resources, how to manage better the resources. They can go to a, let's say, sort of broker, maybe an operator, and say, okay, we trust you, these are our resources, make the best out of those. You can even sell part of the capabilities of our resources to third parties. We want to be free of dealing with this. For other providers, for other customers, for instance, banks, probably they want to be in charge of what is going on. So they say, yes, part of our processing, part of our storage will be integrated in this infrastructure, but we want to have the total control of what is going on. We just federate it with other communication capabilities. The important point is to understand the distribution of the logic of the application. And there it strongly depends on the kind of application that you are thinking. Certain could be simple client server with a very simple view of the network. Other could be very, very complicated, very distributed, and they should be supported by a good application environment and a detailed enough view on the resources they are using. So, some lesson learned. We are at the very beginning. Complexity of the network environments will increase a lot. Terminals are becoming more and more important. Complexity, we need to cope with the complexity by introducing self-organization of the systems. If communication environments are created on the fly, it's impossible to have a person going there and configuring this out or creating scripts for configuring. So it's up to the terminal to be self-organized. New aggregation models, a new business model will be giving value to terminal and edge nodes. If I'm a user and I made available my resources to the network environment, I should have a return. It could be a social return, it could be an economical return, but those resources have a value, and we have to recognize the value to them. There is the need to create a relationship between the overlay and the virtual environment and the physical environment. There should be this link, otherwise we are virtualizing too much and the physical layer is not supporting that much virtualization. Virtualization, on the other side, is a very powerful way for segmenting the architecture and providing to application the right view on resources. The other point is the network operating system should not force the designer of application tools to follow a distributed approach or a centralized approach. It should be model-free in a way. It should provide capabilities and abstraction. And then for sure, we still have a lot to learn on this new. Thank you.